This is our last video, and so we're looking for monotonic and bounded sequences. And so what does it mean to be monotonic? Monotonic means that our sequence is either increasing or decreasing. So if it's increasing, that means each next term must be bigger than the previous term. So 1, 2, 4, these are getting bigger. Something that's decreasing to 1, 1/2, 1/3, -2, it is getting smaller for all n greater than 1 and for all n greater than 1. A sequence is bounded if it's bounded above and below. And so if it's bounded below, that means we have some lower number that our sequence is equal to. It will not go below. And if it's bounded above, we have some number that our sequence will not go above. So let's look at some examples of these situations. How about one that's bounded but not monotonic? So if you think of cosine starts at 1 and it does that nice little curve. So as we place little dots on here, right? Those are our terms. So as n goes through, it looks like this. So that's term 1, term 2, term 3, term 4, and you can go through all of them. 1, 2, 3, 4, there's term 8. But you can see it's decreasing and increasing, which means it is not monotonic. This is not monotonic, but it is bounded. If you go back and look, we know the cosine will not go below -1, and it will not go above +1. So we know that our a sub n has to be between -1 and 1 for all n greater than or equal to 1. So as we plug 1 in and 2 in and 3 in, this is going to be always between -1 and 1. All right, let's look at one now that is monotonic but not bounded. So this one is monotonic, meaning it's either increasing or decreasing. So if we look at our graph, you can see that it is always increasing. And to verify that, you can just find the derivative. If you take the derivative, you'll see that at 1, it's 0. At 2, 3, that it is always positive. And so if we take the derivative, we'll be able to see this. So if we call this f of x equals x cubed minus 3x plus 1, and we take our derivative, and we end up with this. So if we set this equal to 0, you can see that we get 3x minus 1, x squared, and that would be 3x minus 1, x plus 1 equals 0. So we get x equals 1 and x equals -1. Now our x here is going to be greater than or equal to 1 because we're talking about n being plugged in. So we can just cross that off and say, well, it's at 1. So that means everything that's bigger than 1 is either always going to be increasing or decreasing. Remember, we can plug these in. That's 1. And then now if you do f prime and pick any number like 100, and we plug that in, you can see it would become positive, which means it's increasing. So we can use our derivatives just like before to show this. Because remember, they're going to just go along that curve, and we're plugging them in. So the only real difference here that you can see is we have our function, which is every single point, every single x value. And making it a general term means we're just plugging in our integers, 1, 2, 3, 4, getting this. So you can see that it's always increasing, which means it is monotonic. But it's not bounded, because if it's always increasing, right, it's not always increasing to some value here. We can see this is always going up, right? But it is bounded at the bottom. So if we go all the way back to 1, you can see that at 1, -1, that is the smallest value. So you can say it's bounded below with a sub n, by a sub 1 equals 1. So we know our a sub n has to be greater than or equal to, -1. That's what we got, right? So to find this, all you have to really do is plug 1 into our function, and that would be 1, and 1 is 2, minus 3, which would be -1. So it's bounded below. Let me just show you that. A sub 1 is -1. So it's bounded below by -1. But it is monotonic because it's increasing. So what we want, though, is we want something that's bounded and monotonic. If it's bounded and monotonic, then we know our sequence is convergent. So if you can show that it's bounded, it has a smallest and a largest value, and that it is always increasing or always decreasing, then we know that our sequence would be convergent. So let's first start with the derivative. So if we do f of x equals, and we take our derivative, we end up with a product rule. So negative 2 e to the negative x, right? And then minus 2x e to the negative x times negative 1. So we have negative 2 e to the negative x plus 2x e to the negative x. So we can factor out a 2 e to the negative x. In fact, yeah, we'll just do that. And we end up with negative 1 plus and x. We set this equal to 0, and you can see that we get x equals 1. So it's the same basic idea as above. So if I plug in 1, and again, our x here is going to be greater than or equal to 1, because our n will be greater than or equal to 1. We just have to plug something into our derivative like 100. So if I plug 100 in, but we already know that this is monotonic. We just are looking now, is it increasing or decreasing? So if I plug in 100, that becomes positive. That will always be positive. So we know it is increasing. So it is increasing on 1 to infinity. We always want to keep those parentheses because we are looking at an interval. And so this means that our a sub n is increasing. Now if we can show that it's bounded, well, then we show that it is also convergent. And so if we look at the graph, you can see here that it is bounded. We've got some smallest value here, right? And that's when we plug in 1. And then we have some largest value. So as I move through here, our largest value is 3. So it is completely bounded. Look at that again. So our smallest value is a sub 1. And we know that's going to be the smallest value because our function is increasing, which means our sequence is increasing. So since we're starting at 2.264, we know that is the smallest amount. And then it's increasing all the way until the limit, which is our 3. So it is also bounded by a sub n, which is whatever we get for that beginning, and 3. So I'm going to find a sub 1 here. And again, we're increasing from there. So 3 minus 2, plugging in 1, e to the negative 1. And this would give us 3 minus 2 over e. So we know it's bounded on that interval. And a sub n is increasing. So we know this sequence is convergent. And so we could use a calculator to find this because all we're looking for is bounded and monotonic. We're not actually asked to find the limit. But yeah, if you wanted to take the limit of this, you would see that it would become 3. Use a little L'Hopital's rule in there. And there you go. So monotonic just means is the function increasing or decreasing. So you can look at the derivative and tell if it's increasing always or decreasing always. And if it's not, it is not monotonic. And if it is not bounded, well, then it's not bounded. But if it's a bounded monotonic sequence, it's convergent.